All right. So yesterday we talked about side, 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 and side angle side. Today we're talking about three more that are on the reference page that you got yesterday. So let's go to the reference page real quick. Get that reference page out from yesterday real quick, and then we'll talk about what we're looking at here. We're going to be completing everything up until CPCTC. We'll talk more about that tomorrow. So here we go. With angle, side, angle, that's one of them we're going to be talking about today. Angle, side, angle means you have two angles with a side that's included, as opposed to side, angle, side, which is two sides with an angle included. So this is from yesterday, this reference paper here. So I'm going to say, let's see, that angle there, this angle up here, and this angle up here. And so the included side between those two would be that side and that side. So, angle, side, angle. So instead of two sides with the angle in between, it's two angles with the side in between. And then the last one we're going to be, well, not the last one, the second to last one. This last one is kind of a special case, but we'll talk about that as well today. Angle, angle, side means two pairs of angles and a side opposite those angles. So basically a non-included side, which could be this side here and here, or it could be that side there and there. It doesn't actually matter. If you have two angles in a non-included side, we can do that. Angle, angle, side. All right, now the last one, this one's called HL. Because it only works with what kind of triangle? What kind of triangles are those? Right triangles, yeah. These only work with right triangles. H stands for hypotenuse, which only exists on right triangles. And then a leg is also part of a right triangle. So we have the hypotenuse is congruent, which are the longest side, the ones across from the right angle. And then either of the legs that are congruent as well. So the legs are just the other side. So those two right there. It could have been the ones that were up and down as well. It doesn't really matter. But if you have right triangles, you know that you have two congruent angles already, because you got 90 no matter what. And so as long as the hypotenuses are the same and the legs are the same, or a pair of legs are the same, you've got HL. Now, it also works, by the way, if these two pairs of sides are congruent instead of the hypotenuses, but at that point, it's just side, angle, side, which we learned yesterday. So this one's in addition to that. So we're doing angle, side, angle, 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 side, and HL today. And in terms of the reasons why the sides and angles are congruent, same ones as we were dealing with yesterday. So today is all proofs. We're going to be, like I said, I'm going to try to be pretty quick with them, just because the reasons we're using today are basically the same reasons we used yesterday. So let's get ourselves ready and we will move on. All right, so let's move on to our notes here. So we're just going to go ahead and fill these in. So this is basically what we saw yesterday, except there are different parts now that are congruent. So this one says if, let's start with the ones that have single markings on the angles. So angle A is congruent to angle D. And then we're going to move on to the sides that are congruent. So that would be AB is congruent to DE. And the other pair of angles, angle B is congruent to angle E. Then the two triangles are congruent because of angle, side, angle. Again, included means between the two other things. So this time the included side means the side in between the angles. as opposed to yesterday when we had the angle in between the sides. So we're going to say triangle ABC is congruent to triangle DEF. So the results of all of these are the same. You get congruent triangles. But if you have, the different parts being congruent, you can end up writing your statements. All right, let's go to our first proof here. So all the information, all the statements are already done. We're just going to fill in some reasons. Some of these we will have to do entirely on our own, but a lot of them will be set up for us already. All right, so let's see. There's nothing really we can mark on the diagram based on the given, not yet anyway, but we'll get to that. So here we go. Statement number 1, what's the reason? Given, yeah. All right, statement number 2 says that angle RQS, that's that one there, is congruent to angle TQS, which is that one there. Yeah. So those two angles are congruent based on, what did we just talk about right here? Angle bisector, yeah. Remember your reference page, still going to be useful here. If something is talking about angles being bisected and then you talk about congruent angles right after that, it's probably definition of angle bisector. The definition of angle bisector. All right, next one says angle RSQ, that's this one here, is congruent to angle TSQ, which is the one right underneath it. What's our reason there? That'll be the reason that we end up using to prove the triangle's congruent at the end. We're still talking about congruent angles here. How many angles are bisected in the given? 2. This statement uses one of those angle bisectors. This statement uses the other one. So it's the same reason as reason number 2, definition of angle bisector. What's that? How do we know it's that? All right, next one, 4. QS is congruent to QS. Reflexive, yeah. Something is congruent to itself, that's a reflexive property. And then number 5, why are they congruent? Angle side angle, yeah. We have 2 pairs of angles with the side in between the 2 pairs of congruent angles, therefore angle side angle. The next one will also be angle side angle. These first 2 we are practicing, actually the first 3 we're practicing angle side angle. So we can be assured that the final reason for each of the first 3 proofs will be angle side angle. All right, questions on number 1 before we look at number 2? Okay, let's keep going then. Number 2. Definitely given. Yeah, I'm actually going to mark some stuff on the diagram first. So JK is parallel to LM. So that means that that side is parallel to that one. It also tells us that JL is parallel to KM. So I'm going to put parallel markings with those ones as well. So the 2 sides are parallel and the top and the bottom are also parallel. And then going here, reason number 1 is given. All right. So next thing, it says that angle JKL, that's this one here, is congruent to angle MLK, which is that one there. If you go to your reference guide from yesterday and you look at look for reasons why angles are congruent, these 3 here have to do with parallel lines. So chances are we're using one of these 3. So if you look at the 2 angles we just said are congruent to each other, which of those 3 does it relate to? Alternate interior, yeah. So alternate interior angles. All right. Why is it not next to? Because if you look at where those angles are, they're in between the parallel lines. They're not outside of the parallel lines. So if they were like out here somewhere, then they would be exterior, but because they're confined within the parallel lines inside of them, that makes them interior. Next one, angle JLK. So JLK, that's this one up here, is congruent to angle MKL down there. What's our reason? Alternate interior, yeah, it's the same. There are two sets of alternate interior angles here, and we just showed that both of them were congruent to each other. So again, alternate interior angles. All right. And then it says that KL is congruent to KL. I think it should say KL is congruent to LK. We'll brush over that a little bit. So that one right there. What's the reason? Reflexive, yeah, because it's the same thing. And then we'll finish up with angle side angle, because the side is in between the two angles that are congruent. Cool. So these proofs are basically the same thing we did yesterday. It's just different parts to show that the triangles are congruent. All right, turn the page over. This is basically all we're doing today. Just a bunch of proofs using the reference guide, trying to figure out what's going on. All right, here we go. BAC, angle BAC, that is that one down there, is congruent to angle DEC. That's this one up here. That one's given, so that's nice. C is the midpoint of AE. We're going to have to do this entire proof on our own. So here we go. Starting off with angle BAC is congruent to angle DEC. That is given. C is the midpoint of AE. That's also given. If you have a midpoint, we should probably be using the definition of midpoint. So if the C is the midpoint of AE, what does that tell us about congruent segments between those 2 points? Which segments have to be congruent because C is the middle between A and E? AC and CE. Yeah. We're going to write EC. So AC is congruent to EC. And that would be definition of midpoint. All right. So this side, right, these two sides need to be in between two angles that are congruent to each other from each of the triangles. So what other set of angles are we going to need to show that are congruent here? And what are we going to use to show that? What other pair of angles do we know have to be congruent here? Which ones? So this one up here and this one here? So if we were using angle side, yes. And we don't actually have enough information to say that those two are the same. Which ones do we know have to be the same, even though we're not provided any prior information about them? How about the ones in the middle? Why do those two have to be congruent? They're vertical. Yeah, vertical angles are the ones that are across from each other when lines intersect. Therefore, they have to be congruent to each other without any prior information. We know that they have to be congruent. So that would be, let's say, angle. We can just use the triangle letters, but use angle instead, the symbol for angle instead. So angle ABC is congruent to angle. That's not ABC, sorry. We can't do that. Angle BCA is congruent to angle DCE. There we go. That's better. And that is because of vertical angles. All right. So now we have, I wrote a wrong thing here. I put things in the wrong order. All right, and then the last thing is going to be the thing we're trying to prove, which is triangle ABC is congruent to triangle EDC. And we are using angle side angle for these first three proofs. So there we go. That's number 3. What's that? If I were to say what part, don't say all of it. But like, is there a specific part in here that is tripping you up? The given part makes sense, yeah? Yeah? Serenity. Vicky is asking a question. So the givens are good, yeah?
Number 3.
Number 3, this one here. Step 3. So because C is the midpoint of AE, so if you look at the diagram, C is in the middle of A and E, which means that the distance from here to here is the same as the distance from here to here. So that's our definition of midpoint. Yeah. And then those two angles had to be the same because they're vertical. What's that? That's what I was just talking about. Those two angles in the middle, that's this here. And they have to be congruent because they're vertical. Vertical angles are always congruent. All right, let's keep going here. Angle, side. So this time, if you have two angles and a side that is not in between the two, the triangles are still congruent, which is kind of convenient. So if angle A is congruent to angle D, and if angle B is congruent to angle E, and side length BC is congruent to side length EF, then the two triangles are congruent. Triangle ABC is congruent to triangle DEF. So angle, side instead of angle, side, angle. This time the side is not in between the two angles. It's outside the two angles, but the triangles are still congruent. All right. So moving on to our next proof. We're going to be using angle, side for these next few. We are told that YZ bisects angle WYX, and we are told that angle YWZ is congruent to YXZ. So YWZ, YXZ, those are congruent. It tells us that, so I'm just going to mark those. And then I'm going to start it in the proof. So statement-wise, we have YZ bisects angle WYX. That's given.
Wait, you don't write the...
So we have the congruent markings for the other given, which is angle YWZ is congruent to angle YXZ. So those are congruent because it tells us. Now, I'm actually going to do something a little bit different on this one. I'm not going to put the next given yet. Just because, I mean, you can. There's no problem with doing that. If you want to do that, you're welcome to do that. However, because this one was written first, the angle bisector, I would prefer to use this angle bisector right now to say that two other angles are congruent before writing the next congruent statement from the given. It's up to you, though. You can do it in whatever order you want to, as long as you have the correct information. I would just rather use this right away. So if YZ right here is cutting in half angle WYX, this angle at the top has been cut in half. That means that this part of it is congruent to that part of it. Those two sides of that angle up top are congruent to each other. So that means that angle WYZ is congruent to angle XYZ. And that's because of the definition of angle bisector. So definition of angle bisector.
Oh my.
So usually, like, and this is my personal preference on a proof. If there is the statement about something being an angle bisector, I'm going to follow that up with what ends up becoming congruent because of that before I write the next given. So I'm just going to go ahead and start with that. If you want to do given always, that's fine. And then move on to the next things after that. Totally fine. Next one, I'm just going to put the other given. Angle YWZ is congruent to angle YXZ, and that was given. No, it actually doesn't. So a lot of the times the order that you write your proof in doesn't always matter the order that you do it. This is an example of that, where the order of those things doesn't need to be in any particular order. The next thing we need to do is prove that one pair of sides are congruent. Which pair of sides do we know have to be congruent, even though there's no information about it in the given? Those ones No, we can't make that statement. There's not enough information given to make that statement. Which one is there definitely enough information though, in terms of sides that are the same? Yeah, YZ has to be congruent to itself because it's on both triangles. Any side that's on both triangles must be congruent. Excuse me. So this would be side length, so it'll be YZ. And we're actually going to do the same order for this one, is congruent to YZ. And the reason, again, is if you look back up at the thing you were trying to prove, if you look at YZ on the first triangle, it matches up with YZ on the second. So just follow that order. This is the reflexive property. And then we can say that triangle WYZ is congruent to triangle XYZ because of angle, side. Okay. Let's keep going. What's that? Yeah, right here. I'm only going to pick one more from the next three. And then we'll move on and talk about HL real quick. Okay. So, and I think I want to double check though. I just want to have a quick check here just to make sure. I think all of these are angle side, but I'm not entirely convinced. Let's see. Yeah, they're all angle side. Cool. So let's go with let's just do number 5 and we'll skip 6 and 7. So problem number 5, we are told 3 things actually. We're told that angle ABC, this one up here, is congruent to angle CED, this one up here. We are told that segment AB is parallel to segment CE, so we'll go ahead and do that as well. With parallel markings on there. And then we're also told that C is the midpoint of AD. That will give us congruent segments, but we can't say it yet because we have to use the definition of midpoint in order to make that happen. So there are 3 things that we are given. That's kind of nice. So let's just go ahead and write those in as given. So here we go. Angle ABC is congruent to angle CED. That's, well, I'm going to fit AB as parallel to CE as well on here. Those are both given. Again, if it's the same reason, you can put multiple things on the same line if you have the same reason for it, or you can separate it out. It's up to you. Next one, C is the midpoint of segment AD, also given. So all 3 givens on the first 2 lines. All right, what I'd like to do next is use the fact that C is halfway in between A and D. What segments would be congruent because of that? AC and CD, exactly. So that one is congruent to that one. So segment AC is congruent to segment CD. That would be definition of midpoint. All right, so right now we have 1 pair of angles. We have 1 pair of sides. We need another pair of angles. We also have parallel lines. That's a hint. If you have parallel lines, that generally creates some congruent angles. Which one? This one here and that one there. Yeah. So because we have parallel lines here and here, this is a transversal, meaning angle A and this angle at vertex C are also congruent. I'm saying this angle at vertex C because we cannot call that angle C because there are 3 angles here to deal with. So we have to be specific about that. For that reason, I'm just going to use 3 letters for both of them. So I'm going to say angle BAC is congruent to angle ECD. Now those angles are congruent because of some parallel lines that we have. And if you look at those two angles and you go to your reference guide, this angle here with the double marking, that angle there with the double marking, are we looking at alternate interior, alternate exterior, or corresponding angles? Alternate interior would be like here and then on the opposite side down under here.
So A and B.
A and C because of what? So it's not alternate interior. They're both on the same side of the transversal. Same side interior would be supplementary, but that's not one of our options here. They're corresponding, yeah. So this one here and this one here are corresponding angles. Corresponding angles are congruent, so that would be corresponding angles. And since we mushed together a couple of our givens, we can go and finish our proof here. We can go ahead and just use 5 of the lines instead of all 6. Triangle ABC is congruent to triangle CED. And this would be because of angle, angle, side. 2 angles with a non-included side. All right.
Wait, so the last one we're gonna-
No, because we grouped together a couple givens on the same line up top. So if we would have separated out all the givens on separate lines, it would have used all 6 lines, but we grouped a couple together. Okay, let's have ourselves a look at HL, hypotenuse leg. These ones, the next ones we're going to be talking about, only work with right triangles. Hypotenuse leg, hypotenuses only happen on right triangles. So if you have a right triangle and you have the hypotenuse is congruent, that would be BC is congruent to EF. And one other pair of legs congruent. In this case, this would be AB is congruent to DE. Then the 2 triangles are congruent. So triangle ABC is congruent to triangle DEF. So the result, once again, is exactly the same as all the other results. However, this is on the very back. So the hypotenuse is always the longest side of a right triangle. It's always across from the right angle. That one right there. And a leg is just one of the other 2 sides. So HL proofs tend to be a little bit shorter because there's less to prove that parts that are congruent between them. So here we go. Let's have a look at an HL. So it says that triangle LMP and triangle NNP are right triangles. Why do we know that? What's the reason number 1? It's given. Yeah, it tells us that. And it says that ML is congruent to MN. So those 2 sides are the same, which is also given. And then it says that MP is congruent to MP. It's the same thing, so what's the reason? Reflexive property. And so we have a right triangle with the hypotenuses ML and MN congruent and a leg MP congruent to MP, which means the 2 triangles are congruent by HL. We have the hypotenuses and 1 pair of legs. That's it. We're gonna do 1 more. We'll do number 2 and then we're done. And have hopefully about 15 minutes to get working on your assignment as well. For these ones, yes. If you start with something being a right triangle, chances are you're going to use HL. If you don't have information about a right triangle, chances are you're going to use one of the other 4. All right. So here we go. Triangle WVX and triangle YZX are right triangles. Okay. So let's just go ahead and write that in. Triangle WVX and triangle YZX are right triangles. That's given. All right. Now here's the weird thing about this. Which ones are the right angles? Do we know? V and Z, right? Yeah. So V and Z. Those are our right angles, which is important to know where the right angles are, because if you don't know where the right angle is, then you don't know where the hypotenuse is, which is a very important part of this process. WV is congruent to YZ. Those are not the hypotenuses. Those are some legs. Yeah, we can write that in statement number 2. So WV is congruent to YZ, and that's also given. So given for that one. And then also we have X is the midpoint of WY, which is also given. A lot of given stuff here. This is an interesting proof because we don't have to use HL to prove this one. I mean, we should, and we're going to, but we don't have to. It would actually take longer using a different method here to prove that these two triangles are congruent, but we could definitely use a different method for this one. We could use angle side for this. We would have to say that angle V and angle Z are right angles because of the definition of a right triangle. We would then have to say that V and Z are congruent because all right angles are congruent. And then we could say that these two in the middle are congruent because they're vertical angles. And then we could use angle side. That is possible here. It would be a lot longer to do it that way, but I just wanted to mention that because when you're writing a proof, there isn't always just one thing to do in order to get the right answer. Like there's oftentimes many different ways that you can actually construct a proof to get to the right answer. The proofs that I'm showing you how to do, most of the time I'm showing you the quickest way to prove something is congruent as opposed to the only way. So I just wanted to make sure that was clear before we move on. So let's do this the quick way instead of the long way. So because X is the midpoint of WY, when you have a midpoint, you end up with congruent segments. So X is the middle point between W and Y, which means those two segments are congruent. So that would be WX is congruent to YX. And that would be our definition of midpoint. Those are the hypotenuses. We already had a pair of congruent legs. Therefore, the triangles are congruent. Triangle WVX is congruent to triangle YZX because of HL. And that's it. Tomorrow will be our last lesson of the trimester, actually. Because your last test of the trimester is a week from today, next Tuesday. All right, let me get your